prime factors, we have a couple of ways we can figure it out. And last lesson we looked at using the square root to find the number of primes we have to test to. And this one we're going to look at something called a factor tree. Now you might have seen them before. They look a little something like this. Okay, and that's a tree of all its factors. I'm now going to explain exactly how we use it. Essentially how a factor tree works is we take a number, a composite number, and we divide and divide and divide and divide until all we're left with is its prime factors. So here we can take 16, we can divide it by 8, which is a composite, doesn't matter. We get 2 and 8, we're left with A prime. We then divide 8 again, we can divide it by 4, doesn't matter, 2 and 4. Divide 4 again, we're left with 2 and 2. And at the end, we can look at it and go, okay, so we can't, that's a prime, that's a prime, that's a prime, and that's a prime. We can then say that 16 is equal to 2 times 2 times 2 times 2. And 2 times 2 is 4, times 2 again is 8, and times 2 again is 16. So that is how a factor tree works. We're just taking a composite number and breaking it down over and over and over again until all we're left with is a prime. Let's take our example of our large number 1456 from last video. Now we went through and we figured out that you could divide it by 13 as a prime to start with, and that you were left with 112. And then we went and went, okay, so last lesson we did this by 7. I'm going to do it by 2. 2 and 56. And 56 divided by 2, 2 and 28. 28 divided by 2, 2 and 14. And 14 divided by 2 is 2 and 7. And we decided last lesson that the prime factors of 1, 4, 5, 6 were in fact 13, 7 and 2. 13, 7 and 2. So if I decided to express 1, 4, 5, 6 as a product of its primes, I would write it as 1, 4, 5, 6 equals 2 times 2 times 2 times 2 times 7 times 13. Because I've got 1, 2, 3, 4 lots of 2, 1 lot of 7, and 1 lot of 13. Summarize this video, and it's really simple. Factor trees, all they require us to do is to divide a composite number over and over and over again until all we're left with is prime numbers. And I'll leave you with one final example. 50 is 2 times 25, which is 5 and 5. Prime, prime, prime. 50 equals 2 times 5 times 5.